We're used to seeing it as an immobile symbol, but this structure was never meant to stand. 1,000 tons of reinforced concrete defies gravity at a height of 700 meters above sea level, on a summit where wind speeds exceed 200 kilometers per hour. To understand the greatness of this creation, we must return to 1921. Brazil wanted a symbol for the centenary of its independence. Corcovado Mountain, the Hunchback, was the obvious choice for this location, but the most insane in terms of construction. We're talking about an isolated granite spire, surrounded by tropical forest and exposed to Atlantic storms. Engineer Heitor da Silva Costa won the competition, but his first project was radically different. He envisioned Christ holding a cross and a globe. However, the criticism was harsh. He was ironically called the Christ with a ball. This initial setback pushed Silva Costa to search for the perfect synthesis of art and engineering. The final solution was brilliant. The statue itself would become a cross. Art Deco design, concise, modern, but with a colossal technical problem. How could a cross-shaped structure withstand such powerful lateral winds? In the 1920s, the choice of material was the main dilemma. Many insisted on steel, as with the Eiffel Tower, but Silva Costa made a choice that was unconventional and risky for that time. Reinforced concrete. Steel, exposed to salt-laden sea air, would require excessive maintenance and would rot within decades. Reinforced concrete was the artificial stone of the future, but no one had ever used it for such a complex work of art. The stress calculations were entrusted to Albert Caquot, one of the greatest French structural engineers. Caquot had to calculate resistance not only to its own weight, 1,145 tons, but above all, to wind pressure. Christ's outstretched arms act like a giant sail. During a hurricane, pressure on the structure reaches hundreds of kilograms per square meter. Reinforced concrete provided the necessary rigidity, but created a problem: how to ensure uniform concrete pouring without air pockets at a height of 700 meters, where the climate changes every 10 minutes. While Brazil studied the rock, in Paris, the aesthetic soul was taking shape. Silva Costa understood that to give dignity to concrete, the hand of a great artist was needed. He chose Paul Landowski. Landowski didn't work on Corcovado, but in his studio in Boulogne-Billancourt. Landowski created full-scale plaster models of the head and hands. The head was 3.75 meters tall, each arm 3.20 meters. These models were cut into dozens of pieces, creating negative molds, which were then sent to Rio de Janeiro. Upon arrival, the molds were filled with reinforced concrete directly on site. At that time, this was the largest three-dimensional puzzle in history. Each numbered block had to fit perfectly with the existing internal metal framework. An error of a few millimeters at the base would mean a displacement of several meters at the top. Try to imagine a construction site in 1926. There were no paved roads leading to the summit. The only connection was the Corcovado Railway, a rack railway opened in the late 19th century. Every gram of material, sand, cement, water, scaffolding, and plaster blocks from Paris had to be transported on these small wagons. Space at the summit was so limited that storing large quantities of materials was impossible. The construction site had to be a perfectly synchronized mechanism. What arrived in the morning had to be assembled or poured by evening. Workers lived in extreme isolation, often shrouded in clouds that made the scaffolding slippery and invisible. Despite the complete absence of modern safety systems and the dangerous nature of the site, not a single fatality was recorded during 9 years of construction. A technical feat that for its time bordered on a miracle. If you enjoyed this technical overview and want to know what lies behind the world's greatest works of art, subscribe to the channel.